In this final video on differentiation, we're focusing on how to differentiate logs, both regular logarithms and natural logs, as well as the Euler constant. We're grouping these three together because, as you'll see, they're closely connected. What's super important to remember is that our differentiation game plan hasn't changed. So if you haven't yet watched the video where we explain that game plan, make sure you start there. Otherwise, this one might not make complete sense. All right, let's dive in. We're about to differentiate the following expression. Now here's the key thing. The game plan for differentiation always stays the same, no matter how complicated the expression looks. Step 1 is split up. We split the expression at plus and minus signs, but only if those signs aren't inside brackets, roots, fractions, or exponents. That's super important. So in this expression, we split at the following points. What does split up mean? It means we take one complex expression and break it into smaller, simpler parts. Then we differentiate each of those smaller parts individually, which makes life a whole lot easier. Step 2 of our differentiation game plan is setup. In this step, we use the differentiation structure table to prepare how we'll differentiate in the next step. Important, we're not differentiating yet. We're only setting up the structure so we know exactly how to differentiate when we move on. To do this, we first look at what the x part of each term looks like. But here's something you'll notice right away. Our table doesn't include logs or natural logs. So what now? We're going to handle it exactly like we did with trig functions. We treat logs and natural logs as if they're just a basic x for now. Once we do that, we can easily set up the structure using our familiar table. Important, it doesn't matter what's inside the log or natural log, whether it's just a simple x or a whole bunch of x's all mashed together. In this step, you treat any log or natural log as if it's just a plain simple x. This keeps things simple while we set up the structure. Now we can easily set up the structure. Looking at our first term, we can see it's just a regular x. So the structure we're going to use is this one. In the second term, we've got two x's being multiplied together. So the structure we'll use is this one. In the last term, we've got an x up in the air. In other words, it's in the exponent. So the structure for that will be this one. Once you've set up all your structures correctly, you should end up with this answer. Pause the video here and double check that you've set up your own structures correctly. And with that, step 2 of our game plan is complete. Now for the final step of our game plan. Differentiate. Remember, we only differentiate the parts of the structure that have a d over dx stuck to them, nothing else. Right away, when we look at what we actually have to differentiate, we notice something important. We've got logs and natural logs in our expression, and we haven't differentiated those yet. So the question is, how do we differentiate logs and natural logs? Let's break that down next. The full video is only available to our awesome ebook course students. In our ebook course, all your videos live in one place, together with the ebook and downloadable cheat sheets. No more 2 a.m. doom scrolling on YouTube before a test. Everything's in one spot to help you succeed at Calculus 1 the first time. Let's be honest, I'm not here to convince you of the beauty of calculus. I'm not a professor who can talk for 3 hours about how elegant differentiation is. This is damage control to get you through Calc 1 so you can move on with your degree and with your life. This is your please don't ever make me redo this class again plan. And it's all at a student-friendly price that costs less than a mid-tier restaurant meal. Not even steakhouse level, more like a fancy burger with just one side. See you inside the ebook course.